In this question, you're given the quadratic equation a minus 5 times x square minus 2ax plus a minus 4 is equal to 0. And one root of this equation has to be smaller than 1 and the other root has to be greater than 2. So if that is so, what is the range of a? So now for these conditions to be satisfied, how should the graph look like? So 1 and 2. So one root has to be smaller than 1 and the other root has to be greater than 2. That means the graph has to look like this. So what are the conditions which ensure that the graph looks like this? So the first condition is discriminant has to be positive. And the next conditions are just that the functional values at 1 and the functional value at 2 has to be less than 0. The functional value at 1 has to be negative. The functional value at 2 also has to be negative. So if these two conditions are valid, as well as discriminant is greater than or equal to 0, the condition one root smaller than 1 and the other root greater than 2 will be satisfied. So let us solve these conditions. So first, 4a square minus 4 times a minus 5 times a minus 4 is greater than or equal to 0. So this 4 and this 4 gets cancelled. This implies a square minus of a square minus 9a plus 20 is greater than or equal to 0. So this a square and a square gets cancelled. So this implies 9a minus 20 is greater than or equal to 0. This implies a is greater than or equal to 20 by 9. A is greater than or equal to 20 by 9. So now, one condition, the answer is a is greater than or equal to 20 by 9. Next, the functional value at 1 is negative. But as we know, these conditions have to be applied only in transformed equations. Here, the leading coefficient is a minus 5. We don't know whether a minus 5 is positive or negative. So one of the options are, you can solve this in two stages. That is, we need the leading coefficient to be positive and f of 1 to be negative, leading coefficient to be positive and f of 2 to be negative. So that is one way. Or you can divide the whole equation and form the transformed equation and get the answer from that. So what is a transformed equation? X square minus 2ax by a minus 5 plus a minus 4 by a minus 5 is equal to 0. So this is the transformed equation whose leading coefficient is positive. Now apply these conditions for this equation. So f of 1 is negative, that is 1 minus 2a by a minus 5 plus a minus 4 by a minus 5 is less than 0. So if you take the LCM, you get a minus 5 minus 2a plus a minus 4 by a minus 5 is negative. So a plus a, 2a minus 2a gets cancelled. So minus 9 by a minus 5 is negative. This implies a minus 5 has to be positive, right? Because you have a negative number in the numerator and effectively you want a negative number. So a minus 5 has to be positive. So a is greater than 5. So if f of 1 has to be negative, a has to be greater than 5. So f of 2 has to be negative. So let us put x is equal to 2. So 4 minus 4a plus a minus 4 total by a minus 5 has to be negative. So this implies if you take the LCM, so this minus is not common to all of this. So this is minus 4a, right? So this implies if you take the LCM, 4a minus 20, 4a minus 20 minus 4a plus a minus 4 by a minus 5 has to be less than 0. So 4a and 4a gets cancelled. So you get a minus 24 by a minus 5 has to be less than 0. So if you draw the wavy curve for this, you have 5 and 24. The wavy curve looks like this, plus minus plus. I want my expression to be negative, hence a belongs to 5, 24. A belongs to 5 to 24. So this is the next condition. So what is the common condition to all of this? So first, let us plot all the conditions on a single number line and see the common solution. So let us draw the number line. So the first condition is a has to be greater than 20 by 9. The next condition is a is greater than 5. So 20 by 9 is 2 point something. So 5 lies somewhere on the right side of this. So a is greater than 5 as the second condition. The third condition is a is in between 5 and 24. So you have 24 somewhere here. So a has to lie in between 5 and 24. So what is the common solution to all this? As you can very clearly see, the common solution is a lies between 5 and 24. So a belongs to 5, 24 is the common solution to all the three solutions. So this is the answer to this question. Thank you.